So now that we've talked about binders, we're going to talk about negators. And negators are often used in conjunction with functors or other binders and so on. And what a negator does is it's used to store a functor that, when evaluated, will return the opposite result of the functor that was evaluated. And there's three different variants of this. There's not one, not two, and not fun. And actually, I think it's not FN. So we'll see when we look at the code. And let's go ahead and take a look at this. We're going to look at a bunch of examples of these. And what they're going to do is, as you can imagine from here, is that not one is going to negate the result of a unary operator. Not two is going to negate the result of a binary operator. And not fun is going to negate the result of a unary or binary operator. So now we're going to go ahead and take a look at some examples. And these are in my 9.3 folder on my GitHub account, so you can follow along if you'd like. So now we're going to take a look at an example that demonstrates the various negators, and you'll see that they get used in conjunction with other things, other kinds of functors. That's what makes a negator. A negator is it negates the results of something else, which is typically a functor. So not one, as we talked about, is going to negate the results of a unary op, and negate two will negate the results of a binary op, and not fun, or not FN, or not function, I guess I should call it, negates results of either a unary or binary op. And it uses some C++ template magic to make all that work properly. So to show how this works, we're going to make a little adapter, or rather, we're going to make a little functor. This is an arithmetic functor that's going to return the Boolean predicate true or false if a value is odd. And so, as you can see in this particular case, it takes a unary function, or it is a unary function, so it's going to have a single parameter. And in this case, it's type name t, and the function call operation simply goes ahead and mods the result of number by 2. And if it comes back being not equal to 0, we know it was odd. If it comes back equal to 0, we know it was even. So it's just a simple way of determining what the value is. So now we're going to talk about negators, and I'll show you some examples of how to use negators in practice. Negators, there are three different variants of them. Not one, which is going to take a unary operation. Not two, which takes a binary operation and negates it, of course. And then not FN, or not function, which will use some template magic to negate either a unary or binary operation. To show this, we're going to have a little isOdd functor, which is a unary function. And you can see that it takes parameter of type t. And if that parameter modded by 2 does not equal 0, we know it's odd. Otherwise, if it's modded by 2 and it equals 0, we know it's even. So here's the program that's going to use to test this. We're going to show off the remove copyIf and copyIf algorithms, and the not one and not function negators. The vector we're going to give is just going to have the value 1, 2, 3, 4. Doesn't matter that they're ordered. And then we go ahead and remove all the even numbers by using the not one negator. So what this is going to do is it's going to take the odd functor and negate it. So of course, isOdd returns true if something is odd, and we're going to negate it so it'll return true now if something's even, and we're going to use remove copyIf to remove all the even numbers. And we do that by walking through vector v1 from beginning to end, and then we back insert the results, which will of course only be the odd numbers that make it through the test, through the predicate, and those get stuck at the end of vector 2 using the back inserter. So let's see if we get lucky and we can get remove copyIf, and we do. And you can see what remove copyIf does is it takes 2 input iterator parameters, which correspond to the range we're iterating over. It takes an output iterator parameter where the result's going to go, and it takes a predicate that's going to determine whether or not we copy something or not. And we go through the range from beginning to end. And anytime we don't get a match, so in other words, if the predicate is false but not true, in that case, we copy the contents of the item into the output iterator and increment the output iterator, and then increment the input iterator. But you can see here what we're going to do is we're going to skip over everything that matches. So that's why it's remove copyIf. So we're only going to copy things if they don't match the predicate. So that's why it's phrased in that way. It's kind of a weird way to phrase it. So remove copy if, in this case, is going to get rid of everything that's not odd. Then we print the results. Now for kicks, we're going to make ourselves a deck instead of a vector here. And we're going to use remove copy if, except this time, instead of using not one, we're going to use not function or not fn. Same behavior. They both do the same thing. Let's go ahead and take a look at not one to see how it's defined. So here's not one. You can see that not one takes its parameter and returns a unary negate object, which encapsulates the predicate here by reference. And here's the unary negate operation. You can see it stashes aside the predicate, which is the functor, as the parameter passed to it. And then its operation function call will call that predicate and then reverse the result. So it'll negate it. That's what not one does. That has been deprecated. Not function or not fn uses this pointer, or not this pointer, this template magic with the thing called not fun impl, and it goes ahead and forwards in the parameters that pass to it. And the long and the short of it is, without getting wrapped up into too much gory detail about how all these things work under the hood, is that this not function negator will work for both binary and unary operations correctly, whereas with not one and not two, you have to specify whether it's unary or binary. So that's why they moved away from that to this newer approach. Once we're done inserting all the numbers that are not even in this approach using not function, we then print the results. We then resize the vector, or actually resize the deck. And once we've resized the deck, then we're going to go ahead and do the whole thing over again, except this time we're going to make two changes. First, we're going to go ahead and use a lambda function instead of negators and adapters and other functors. And we're going to use copy if instead of remove copy if. So what we're going to do here is we're going to copy the odd numbers by checking to see whether something is odd. And then instead of doing remove copy if and having to negate that, we're going to go ahead and do a copy if it in fact matches. And so then we go ahead and write the results at the bottom. And let's go ahead and add in IOStream. So now let's go ahead and take a look at this print results function. I've been using this to print the results, and it's kind of fun to see how this works. This is a little variant on a theme just to show you other ways of doing things. This is a template that's parameterized by a template. So it's a template parameter. And in this case, as you can see, it's going to be parameterized by a sequential container. And so print results takes a const ref, which is a sequential container of type T, and it's going to start at the beginning of the container and go to the end of the container and write the container to the standard output. So let's go ahead and run this program, and you'll see what it does, of course, is each of those approaches removes the even numbers. And the first two approaches demonstrate different types of negators, not one and not function. And then the third example uses a generic lambda along with copy if. So hopefully that helps to clarify how all those things work. Okay, we're now going to take yet another look at using negators, and this will show us with a bunch of different variants, the not one, the not two, and the not function negators, and then we'll also illustrate them in the context of the find if and find if not STL algorithms, and we'll also throw in a nice generic lambda function for good measure just to demonstrate that as well. So let's first start by defining an overly specific functor, just for kicks. This is called int greater than 3, and my goodness, is it overly specific. I don't think anybody would ever write one like this in practice for reasons that'll become clear in a second, but I'm doing this just to demonstrate the idea. So down here we define ourselves a vector of ints, and you can see that we're going to first do find if with the range from beginning to end of the vector of ints, which is not ordered by any means. And what we're going to do is we're going to find the first element whose value is not greater than 3. So the first element whose value is not greater than 3, of course, is 1. And we get back this iterator here, and then we're going to print from that iterator, which we'll be pointing to here, to up to but not including the last element. Or actually, we include the last element, we don't include the end iterator. So we're going to print off the range from where we found the first item not greater than 3 to the end of that range. I could also have used bind second here, except that that's a deprecated function, so we're going to ignore that. Instead, I'm going to show how to do the same thing, except this time I'm going to use the not function method, so that'll invert something, negate it, and bind, and in this case, instead of writing an overly specific functor int greater than 3, I'm going to define myself an anonymous bound functor, which is going to bind the greater functor with a placeholder with the value 3. And so what that'll do is that'll return true if something is greater than 3, and then we're going to negate it with not function. So that'll return true if it's not greater than 3. And of course, again, we should get the value 1 as the first element in this range that's not greater than 3. Then the next thing we're going to do, just for kicks, is we're going to go through that range from beginning to end, except we're going to use find if not. And what find if not does is it actually goes the other way. So you can see here, whereas find if will go from beginning to end, what find if not does is it's going to go through and negate the predicate. So it's going to go through the range and it's going to find the first thing that's not what we're looking for. So in this case, what we're going to do is rather than using a negator, we're going to pass in an anonymous function, anonymous lambda function, and we're going to say return I greater than 3, and then we're doing a find if not. So we don't have to use the negator in that case because we're using an if not predicate version of find. And then when we're done, we're going to go ahead and sort the vector using the not less operation. And I'm only doing this because I want to show you how to use not with not to. So not to works for binary operations. And so that'll be not less is greater. Of course, in real life, you would use greater, but I'm just using this to show not to in action. And you can also put not fun here if you want, and that'll get the same result as not to. And you can see, as I told you before, it goes ahead and we'll always get the first one get a iterator to the first element that's not greater than 3, which is 1, and it prints the results. And then down here, we take the entire range and sort it using not less, which of course is greater. And just for kicks, here is the print results method. And this is kind of an interesting one as well. I use this because, of course, I don't want to print the entire container. I just want to print the part from where the first thing matched from find if or find if not to the end. So I wrote it like this to take an iterator range from first, which is wherever I want to start. It's not the first element. It's the first place where the iterator came back from find if or find if not to the end. And this also demonstrates something fun as well. So if first is not equal to last, we're going to copy the contents from first to last, as we've done repeatedly down here. And then notice how I don't pass in type name key. Instead, I use a very cool feature in C++ called decal type. And what this does is it uses the compiler magic to automatically deduce the type of the element that's pointed to by the first iterator parameter. So star first gets me the actual element that's referenced by the iterator, and then I use decal type in order to derive what the actual type is. And in this case, as you can see, it's going to be int. But more generally, it could be whatever you happen to be parameterizing print results with, which could be double or float or whatever else it is that you're iterating over. So this is a really cool little example of type deduction in action. And it's a good idea to start getting accustomed to doing this because it simplifies the parameters that you have to pass to your generic functions. Okay, so that is the end of the negator discussion.